Hello everyone, my name is Samreen, working as an assistant professor in CSC Data Science Department of LIET Institute of Engineering and Technology, Hyderabad. Today I would like to discuss about basic concepts of operating system. What is an operating system? Operating system is nothing but a program that acts as an intermediate between computer and computer hardware. Nothing but system and system hardware. Why do we use operating system? What is the goal of operating system? It is nothing but it is to make the computer system more convenient to use. Just like whenever we want to give a print out of a Word document, we go and click on a print button. Instead of that if we need to write a program to print a document, then it will be a little hectic. So in order to make the computer system use more convenient and in a more efficient manner, we use an operating system, which is nothing but an intermediate between system and a hardware. Operating system is nothing but a system program. Okay, next, components of operating system. A computer system is divided into four main components: its hardware, its application programs, its operating systems, and the users who are going to access this particular one. So computer hardware consists of CPU, memory, and I/O devices, whereas system and application program consists of compilers, assemblers, text editors, spreadsheets, database systems, etc. Okay, here the operating system, it controls the hardware and coordinate it among the various application programs. That is the job of operating system. Next, computer architecture. A computer may have one or more general purpose computer system which consists of one or more CPUs. A number of device controllers connected to number of device controllers and a CPU are connected through a common bus to a shared memory. Each device control is going to control or have a charge of one specific device. These CPU and device controllers are executed parallelly and they are competing for memory cycles. They are going to work in a synchronized way to access the memory. Next, storage hierarchy. CPU can load instructions from memory. So just like in our computers, our laptops, our mobile phones, we have different types of memories. Instead of only having one hard disk or one RAM memory, we have different types of memories. The reason is it is to balance cost and access time. Just like as we say money, time is money. Over here, the more the access time is, the lesser the cost. The less the access time is, higher the cost. In the top three are registers, cache, and main memory. These are the volatile memories. As whenever the system is going to shut down, these memories are going to be refreshed and there is no data stored in this particular memory. Whereas electronic disk, magnetic disk, optical disk, and magnetic tapes are volatile memory, non-volatile memory. Here, as I said, we are going to have magnetic disks are going to have large amount of memory, whereas registers are going to have less amount of memory. And magnetic disks are going to be more cheaper with more amount of memory. So why we are not using only magnetic tapes? Why are we using registers, cache memories? In order to increase the access time, in order to increase the performance of the memory, in order to increase the performance of the system whenever we are going to access the memory. Over here, the registers may be having of some bytes of memory, cache is going to have some KB of memory, main memory is going to have some GBs of memories. Electronic disks are nothing but they are not going to just like a solid state drive, like our USBs. which are non-volatile, and which are going to be, which they are not as costly as cache memories, but it is not as slow as magnetic disks or magnetic tapes as well. And these optical discs are nothing but just like our CDs, DVDs, and Blu-ray discs. Magnetic magnetic tapes are going to be have some terabytes, some petabytes of memories or hexabytes of memory, which is very huge. But still, as let's consider like to access a magnetic tape, if we take 100 milliseconds to access, the access time of registers will be 1 nanosecond. So to increase the performance, to increase the access time, to decrease the access time, and to increase the performance of system, we use some amount of all these memories in our computer system. Next, how a modern computer works. Whenever we are going to access or send some data from a device to a CPU, over here what happens is there is an IO request. So once an IO request is sent, there is an instructions and data will be accessed from memory and will be executed. And once the data transfer is completed and the device is going to send and interrupt that the transmission or this particular process is completely over. So, but over here we have one drawback, that is whenever we want to transmit a bulk or a block of data, it is not as convenient. So instead of going through our CPU, there is other way called DMA, direct memory access. So over here, as we can see in the image, in DMA the device is directly interacting with the memory. Use over here, why? Because of this, instead of raising many interrupts, only one interrupt is generated per a block rather than one interrupt per one byte. So here the access and transfer of data will be of high speed. Next, types of processors. There are mainly two types of processors. One is single processor, that is nothing but uniprocessor, and a multiprocessor. Single processor is nothing but whenever over here we are having one general, every processor is going to have one general, every single processor is going to have one general purpose processor, and it can consist of multiple special purpose processors. If a processor consists of multiple special purpose processor, it doesn't mean that it is a multiprocessor. As there is only one general purpose processor, the processor is considered as a single processor. The type of processor is classified based on the number of general purpose processors are there. In single processor, we are having only one general purpose processor, and multiple, it can consist of multiple special purpose processors, whereas a multiprocessor can have multiple special purpose processors and multiple general purpose processors as well. Again, this multiprocessor is classified into two types, homogeneous and heterogeneous, nothing but symmetric and asymmetric multiprocessor. Next, let me see about symmetric multipurpose processor, multiprocessing architecture. Over here, all the processors, like just as we have seen, CPU 0, 1, and 2, all are having access to a shared memory. But each and every processor is having its own local register and its own local cache memory. Over here, there is no master and slave. All these processors are peers to each other who are going to do their work simultaneously. Whereas in asymmetric multiprocessing architecture, there is a master and there is a slave, where the master is going to control the slave and give access and control the processes of the slave processors. The last topic is functions of operating system. Nothing but operations of operating system. First one is process management. The process management is nothing but it is used for creating a process, scheduling a process, that which process to be executed when. We have a different scheduling algorithms, which process to be suspended, which process to be again resumed. Yeah, whenever there's a deadlock, how to handle those deadlocks. It provides mechanism for process synchronization, it provides mechanism for process communication. All these things happens in process management. Next is memory management. In memory management, it is going to keep a track that which part of memory is currently used by whom, and which part is being used and who is using that particular part, and it decides which process and data to move into memory and which process and data should be moved out of the memory. Allocating and deallocating of memory spaces as needed. For this, we have different techniques like segmentation technique, paging technique, and all. Next is mass storage management and file management system. These both comes under storage management system only. Mass storage management is nothing but it's a free. It is used to manage the free space. It is used to allocate free space. How to schedule a disk. How to manage a disk. Over here we have different algorithm for this: first come, first serve, shortest seek time first, scan, C-scan, different types of techniques we are using in mass storage management. Whereas in file system management, we are going to it is going to manage how to create a file, deletion of files, creation of disk, directories and deletion of directories, suspending primitives for manipulating a file directory, mapping of files onto secondary storage, backing up of files onto storage media. All these things are done by system management. The last point is protection and security. Protection is about privacy and security. Whenever there is a data and there is resources, we'll protect those data and the resources, that who can access that particular data, who cannot access the data, in order to maintain data authentication, resource authentication, so that no intruders are going to come and use that particular resources. So over here in protection and security, we are going to monitor and maintain the resource in order to not unauthorized users to use and access the resources of the system. This is what the basic overview of operating system. In this session, as we have discussed about basic concepts of operating system, in the further sessions, we'll be discussing about the functions of operating system, which is process management, memory management, storage management, file system, and protection and security. If you like this video, please subscribe to our channel. Thank you for watching.